Hi guys, welcome to another Chelmer Valley Maths tutorial. Mr. Gordon here. We're on the final video of our Core 1 Chapter 1 series, and we were previously looking at manipulating surds. In this section we're going to be looking at rationalizing. Now it says here rationalizing is the process where a surd is moved from the bottom of a fraction to the top, rationalizing the denominator. And we're going to need to make some notes here. I would write these down. These are the rules of how you would do that. So the generalized rules, it says if you've got a over root b, then you multiply the top and bottom by root b. If you've got a over b plus root c, then you need to multiply top and bottom by b and minus root c. That's called the conjugate pair. So it's the same two terms with the opposite sign. Okay, and we've met this before in a previous video. I wonder if you can make the connection as to what topic it was where we had the same two terms in one bracket and the same two terms in another bracket, one with a plus and one with a minus. The difference of two squares is what I'm talking about, and that's very useful in this situation, and we'll come to that later. So the opposite is true as well. If you've got a over b minus root c, then you're going to multiply top and bottom by the same two terms with the opposite sign. So you're going to have a plus instead of a minus. Why do we do that? Let's have a little look and see with some examples. So if we start off with the first one, let's just look at a over root b. So we've got 1 over root 3. Okay, how do we rationalize the denominator? How do we make the bottom of this fraction not a surd? You know, what can we multiply top and bottom by to get an equivalent fraction that will have a integer on the bottom? Because we know that integers are rational. Okay, so a rational number is something that can be expressed as a fraction. Okay, and when all whole numbers can be expressed as fractions. So if we're timesing by, it says here times by whatever the root on the bottom is. So if we times top and bottom by root 3, what do we get? 1 times root 3 is just going to be root 3, and root 3 times root 3 is going to give us root 9. So with fractions, you times the tops times the bottoms, and then you end up with this. So we've got, I've still got a surd on the bottom, well a square root anyway, but it's a square number, so we can simplify that, and we'd end up with root 3 over 3. Okay? So, slightly more complicated is when you've got more than one sort of term on the bottom. We've got this 1 over 3 plus root 2. So, let's think about this. If we multiplied top and bottom just by root 2, would that help? Would that give us an integer on the bottom? Well, if you think about times in this entire bracket, let's imagine having like a root 2 outside. Root 2 times 3 would be 3 root 2, and root 2 times root 2 would give us root 4, which is a whole, we could simplify root 4 to 2. But we'd still have the 3 root 2. So we can't just do what we did before and multiply it by the surd. We've got to come up with a slightly more clever idea. And this is when we turn to the difference of two squares. Because if you multiply the two brackets together, one with the plus, so the same bracket, one with the plus, one with the minus, you will always end up with two terms that are both squared. Now, if you square a surd, we found out before in part 1, if you square a surd, you will always end up with a whole number. So that's how we get round it. We times top and bottom by the conjugate pair. I keep saying this conjugate pair thing. It's actually just the same bracket with the opposite sign. So let's multiply this out slowly. I'm going to bring up the working here. So 1 times the top 1 times 3 minus root 2 is just going to be 3 minus root 2. Then we need to multiply out this bracket, and hopefully we'll end up with no surds on the bottom. So let's have a look. 3 times 3 is going to give us 9. And then we're going to move on to doing root 2 times minus root 2. So plus root 2 times minus root 2 is going to be negative, but it's going to be root 2 times root 2 is root 4. So we'll end up with minus root 4, which has been simplified to 2, because the square root of 4 is 2. Then moving on, we've got root 2 times 3 here, both positive, so the answer will be positive. That's going to give me 3 root 2. And the last two terms are going to be the 3 and the minus root 2. So what does that give me? You've got one plus term, one negative term, so it's going to give you a minus result. So it will be minus 3 root 2. Now, because we've done it in this fashion, just like the difference of two squares, we will always have two terms that cancel out, and it will always be the terms with the surds in. So those two terms will cancel out, and we'll just be left with these two whole numbers, these two integer values here. So then we can just simplify, and we can work this out. It will be 3 minus root 2 all over 7, because 9 minus 2 is 7, and like I said, the other two terms cancel out. So let's look at one more example of this. So this one looks a bit trickier, but again, just follow the rules. We're looking at the bottom. We're trying to rationalise this bit here. So we would times it by the same bracket with the opposite sign. So let's do that, but we must do it to top and bottom to keep it an equivalent fraction. Let's multiply out the top first. So let's do root 5 times root 5. So that's root 25, which then simplifies to 5. Then we've got root 5 times root 2, which is root 10, both positive, so plus root 10. Same in the middle, plus root 2 times root 5, that's a plus root 10. And then we've got, at the end, we've got root 2 times root 2, which we know is root 4, which can be simplified because it's a square number, to 2. So that's the top done. Bottom, root 5 times root 5, again it's going to be 5. We've got minus root 2 times root 5, which is minus, be a minus result, minus root 10. Then we've got the positive version, we've got root 5 times root 2, so plus root 10. Notice how those two terms will both cancel out because we've done the conjugate pair. We've used this difference of two squares idea. And the final bit is minus root 2 times plus root 2, which is going to give us a minus root 4, which again can be simplified to 2, but minus 2. So if we simplify those, look at the top. What can we simplify on the top? Well, we've got we've got one root 10 plus another root 10. So how many root 10s is that? It's going to be 2 root 10s. And we've got the 5 and the 2 on the top, which comes to 7. On the bottom, we've got a plus 5 and a minus 2, which will just be 3. And in the middle, these two terms should cancel out and give us 0. So once we've done that, we should find that we end up with 7 plus 2 root 10s over 3. Okay, so that's the end of the first chapter of the Edexcel A-level course, and we're going to move on to chapter 2. So look for the playlist for chapter 2.